Hey, how you doing? I'm Elton, and this is part 4 of Modernizing .NET Apps for Developers, a series showing you how to run existing .NET Framework apps in containers and use the Docker platform to modernize the application architecture. In part 3, I started to break up my monolithic app, adding a message queue and using asynchronous event publishing for the application save workflow. This new version of the app is easier to scale and upgrade, and with the new architecture, it's very easy to add new features. That's what I'll be doing in this video. I'm going to add a document database and an analytics UI to my app, all running in containers, so business users can have self-service reporting and get real-time insight into the data. Let's go. This is the current architecture of the application. The web app is the public entry point for users. The message queue plugs components together, and the message handler saves data to SQL Server. The database could be running in a container in non-production environments, and an external server, like SQL Azure, in production. SQL Server is great for transactional data that gets used in the system, but it's not so good for end-user reporting. Writing SQL scripts and pasting the output into Excel is time-consuming and boring, and it would be nice to give users their own reporting UI. That's what I'll show you in this module. I'll add a second data store to the application, which will be my reporting database. I'll use Elasticsearch to store flattened data, which is easy to report on, and I'll push data to Elasticsearch with a new message handler. This handler will subscribe to the same event messages that the SQL Server handler uses, so I don't need to change any existing components to add this new capability. I'll start by walking through the new message handler. The message handler to store data in Elasticsearch is another .NET 4.7 console app. The main method starts by initializing the Elasticsearch connection. Then it connects to the message queue and subscribes to the prospect signed up event in the same way as the original handler, so this is all boilerplate code. When this handler receives a signed up event message, it creates a different representation of the prospect data, which is more suitable for reporting. It flattens out nested properties like country and role, and it builds a full name field from the prospect's first and last name. Then it saves that data as a document in Elasticsearch. The index class is just a helper that isolates the Elasticsearch logic. It fetches the URL from app settings and has methods to create the document collection and add the new document. The Docker file for the index handler will be familiar by now. The builder stage does a NuGet restore and MS build to compile the app. Then the final image is packaged on top of Microsoft's .NET 4.7.1 image. There are environment variables for the application folder, the message queue URL, and the path to the app settings config file. And the container starts with a PowerShell script that uses the same pattern you've seen in the series, to allow config to be injected from Docker as a symbolic link inside the container. I want to run Elasticsearch in a container too, but the official Elastic images are only for Linux containers. So if I want to run on Windows, I need to write my own Docker file. I'll be using the Docker files from this GitHub repo, Docker samples/Elastic Windows. I won't go into too much depth on the Docker file, but you can see it uses a multi-stage build, where the first stage downloads the app from the internet, checks the download is safe, and then unzips it. The final stage uses OpenJDK as the base. Elasticsearch is a Java app, and it will run on Microsoft Nano Server, which is the new cut-down version of Windows Server. Then it sets up the ports and copies in the downloaded application. There's even a health check in here that tells Docker how to test that the application inside the container is working correctly. The new message handler and the Elasticsearch container will let me capture and store data in a useful format for reporting. And the last piece to add is a reporting UI. Elasticsearch is a free, open-source document database, and there's an analytics UI that partners it called Kibana. The story for Kibana is the same as Elasticsearch. There's an official Docker image available, but only for Linux, and the sample repo here has a Docker file for Windows. The steps are very similar. The first stage is a downloader, which gets the zip file, checks the hash to make sure the file hasn't been tampered with, and unzips it. Kibana runs on Node.js, and the release ships with the Node runtime, but it's the 32-bit version. You can't run 32-bit apps on Nano Server, so the final image starts from Windows Server Core, which can run 32-bit and 64-bit apps. Kibana gets copied in from the downloader stage, and then there's some PowerShell to update the default configuration file in Kibana. This sets up Kibana to talk to the Elasticsearch container. Modifying config in the Docker file like this is a good pattern for third-party apps, where you want to use the latest official configuration file and just update the values that you want to change. There's a health check in here too, which verifies that Kibana, running on the default port 5601, is responding correctly. These sample Elasticsearch and Kibana images are available on Docker Hub, so I'm not going to build these Docker files locally, I'll just pull the public images. I've added services to my Docker Compose file for my new analytics components. Kibana is showing as depending on Elasticsearch, and I have my new message handler that depends on Elasticsearch and the message queue. My web application and all the other service definitions aren't changed, but I've got an override file that publishes port 80 and 5601 for the web containers. This doesn't apply to every environment, so it's in the local file, and I have a really simple script to run the app locally by combining those two files. I'll run that script. Compose starts all the containers, and I can see when I run docker container list that the components are all running. Now in the app, when I add some data and submit the sign up form, the new message handler gets a copy of the signed up event message. The original save handler is listening, and it saves the row in SQL Server. You can see the new prospect ID in the logs. And I'll check the container logs for the index handler, and you'll see that it has received a copy of the same event and saved the data in Elasticsearch. Now I can browse to port 5601 and see the data in Kibana. This is a completely new installation of Kibana, so I need to configure the data source, which is an index called prospects. Kibana fetches the fields from the document that's already there, which makes it very easy for users to make sense of the data. The simplest view is just a list of all the documents, and here's my data with the business-friendly representation. It's really easy for power users to build and share rich dashboards, and I'll show you an example of that before the end of the series. I've extended my app to add self-service analytics for users by running production-grade open source software in containers and managing everything in Docker. I've broken down the original monolith and styled it with a modern architecture. Event publishing means I can bring in new features which react to existing events, and that enables zero-downtime releases. And these persistence workflows, saving to SQL Server and saving to Elasticsearch, are asynchronous, so I can do extra work here without impacting users of the web app. I could enrich data for Elasticsearch from another system, and that would only add latency to the one message handler component, which I can address by scaling out to run more containers. I'm running 2 data stores now, but that's fine because transactional data and reporting data have different usage characteristics and availability requirements. Both message handlers integrate with configuration in the Docker platform, so I can switch to external data sources. But Elasticsearch is easy to run clustered across multiple containers, so you could run your production document database in Docker too. I'll finish up this video with a look at my production environment, and I'll show you how deployment looks using the Docker Compose file. My application is running in my Docker Enterprise Edition cluster in Azure. The stack is the group of all my application services, and each service is running in one or more containers. This is the version from the previous video, so I'll upgrade to the latest version of the app and add the analytics feature. You use Docker Compose files to deploy to a cluster in the same way that you do to deploy locally on your laptop. There will be different configurations for different environments though, so I have an override file for production. The properties in here only apply to the production clustered environment. In the web app, I'm specifying that there should be multiple replicas, which means Docker will keep 3 containers running for the web app. I also have a constraint saying that the service needs to run on a Windows server. My cluster is a mixture of Linux and Windows nodes, all running Docker and all connected as a single swarm, so I can run any Windows or Linux apps in containers, but Windows containers need to run on Windows nodes and Linux containers on Linux nodes. Docker will figure out that this is a Windows image, but adding the constraint saves the cluster having to work that out. I'm also using a secret for the connection string configuration, and I'm setting the environment variable so the app knows where to read the config from. All the other services have the production settings they need in this file. Joining together the compose file and the production override will give me a complete deployment document. The docker compose config command does that for me. I'll specify the 2 input files, then config will merge them, validate the content, and write the merged output, which I'll capture in a file. This file can live in source control too, or it's easy to generate this as part of your CI process and deploy it to production to give you full CI/CD, just using Docker. I'll deploy it manually for now, so in the stack section, I'll use the name for my sign-up stack, show the verbose output while it runs, and upload the YAML file with the production stack configuration. Deploying a stack in a Docker cluster works in the same way as deploying locally with Docker Compose. Docker compares the current state with the desired state and makes any changes it needs. You'll see it's created services for Kibana, the index handler, and Elasticsearch. I'll check on those services to see that they're up and running. The Elasticsearch service just has 1 container, and I can view the logs which shows the database starting up. And this is the output from the Java logs. Back to the service list, I'll check on Kibana, and when I look at the container logs, you'll see the Node.js log entries responding to GET requests, and that's actually the Docker health check firing. So I deploy and manage all the parts of this app using the same tools, even though they have completely different technology stacks, and some are my custom software and others are open source products. I'll browse to the Azure load balancer for the cluster and verify the app is working correctly. I'll go into the sign up page and add some details and submit the form. It all looks good, so there's been no interruption from the deployment. Now I'll browse to port 5601 and I see Kibana. It's a fresh deployment, so I need to select the prospects data source, and now you'll see the document for the data I've just added. This is the same set of components when I ran the app locally, with the same compose definition now running in a scalable, highly available production Docker environment in the cloud. That's the end of part 4. I've added a new, modern analytics suite to my old application. I've taken advantage of the new architecture I put in place when I broke up the monolithic app, and I'm using enterprise-grade open source software all plugged together with Docker. Adding this sort of capability to your application without Docker would be a significant chunk of work, culminating in a whole new set of components to deploy and manage. With Docker, it's easy, and every part of your application is built, shipped, run, and managed in the same way. And it's exactly the same binaries running in every environment. Next up is the last part of the series, where I'll look at modernizing the application UI. I'll break the application homepage out into a separate component so I can use new UI libraries like Vue.js. That's coming in part 5 of Modernizing .NET Apps for developers. If you want to get started modernizing your own apps with Docker, head to the Play with Docker training site, which is an online environment with Docker configured that has lots of great tutorials. And if you want us at Docker to help you modernize your application suite, head to docker.com/MTA to learn how we partner Docker architects with infrastructure providers like Microsoft and consultancies like Accenture to bring your apps into the modern world.